have covered in the last lecture. So that I can connect the last topic with the topic which I am going to cover. The topic which I am going to cover today is given the title as AC analysis. AC analysis of biasing circuits. So quick recap we will take. What are the different biasing circuits that we have seen? Self-bias, then fixed bias. Self-bias is called as voltage divider bias, and collector to base bias circuit. And quickly I will recap the things what we have covered. We have covered the two numericals each on fixed bias circuit analysis. What basically we are doing in the DC analysis is that we are finding out the quiescent point. What do you mean by quiescent point? Where the amplifier gives the faithful amplification. What do you mean by faithful amplification? The shape of the input waveform is preserved after amplification. There is no saturation. There is only amplification, faithful amplification. If sinusoidal is given in the output, you will get sinusoidal. Then we have seen problem on fixed bias circuit, collector to base bias circuit, and more emphasis was given on the common emitter configuration self bias circuit. We have solved in fact 3 problems in previous couple of lectures. What we have used in that, can anybody tell me which theorem we have used? Thevenin's theorem we have used to find out RTH and VTH. For that I have given you the simple tricks. What is VTH over there is the voltage seen across that input terminal, and RTH is the equivalent resistance seen through that port when DC circuit is short circuit or it is given to ground. So RTH is R1 parallel with R2 and VTH is R2 upon R1 plus R2 into ECC. So is that clear to everyone? Because now today what we are going to do is we are going to go one step forward to that. Now up till now we have emphasized only on the biasing circuit analysis, finding out the Q point, finding out VCE, finding out IC, finding out IE, then IB. All the parameters we could found out by using the DC analysis or Q point analysis method. But now what is the next step? The higher level of difficulty I have started. In fact, what model we have proposed last time? RE model. RE model, emitter resistance model. And for that we have seen, we have made the analogy of a BJT as if at the input there is a diode in the forward bias fashion, and at the output terminal there is a constant current source. Can anybody recall what were the values we have derived last time? If you remember, we have made it like this. Here this was beta RE, and I said that at the output can be seen as a current controlled current source. The value of this is beta IB. This is in fact, it is viewed as a collector amplifies the current signal, collector amplifies current signal with the factor of beta. Beta is what? Current gain, forward current gain of a BJT. And beta RE was what? RE was the forward dynamic resistance of diode, forward bias base to emitter junction. Okay, so this was the equivalent circuit we have drawn for RE model of C configuration. Okay, and after this I have done one more I have told you the simplified steps. If you follow those steps, then you will be able to solve these problems in a very systematic manner, and there won't be any problem for you. You will be able to attempt, because if you will see the first module, we have covered all the things, and the last topic is analysis of common emitter amplifier using RE model. So in the last lecture, I have given you how to draw the AC analysis circuit. Correct? You can just go through the previous pages. We have seen how to draw the AC analysis of the circuit. What all are the steps? Can anybody tell? The coupling capacitor and the bypass capacitor should be shorted. Okay? Then DC sources should be grounded. Okay? First step is to find out RE. How to get RE? What is the formula? 26 millivolt upon. And for finding out IE, finding out IB, we have solved n number of problems by using DC analysis. Is it not? We have found out IB, we have found out IC. What is the relation between IC and IB? IC is beta times IB. And what is the relation between IE and IB? 1 plus beta times IB. Very nice. So based on this foundation, what we will have to do is, now we are not going to restrict the circuit diagram just as a biasing circuit. We are going to make it as an amplifier. How will we make it as an amplifier? By giving some input. There will be some AC input. In fact, I have drawn some circuit, standard circuit also, standard common emitter amplifier circuit also we have drawn, wherein input capacitor and output capacitor was introduced and a bypass capacitor was introduced. So that is a typical common emitter configuration circuit. And I told you that what is the need of coupling capacitors? Because once we set DC, DCC and all the quiescent point, once we set, it tends to deviate at the application of input voltage, which is sinusoidal with frequency. So how to avoid the impact of that input is by applying the capacitor. We are putting capacitor at the input as well as at the output. So that is called as coupling capacitor. To couple means to connect in between. So in between input and BJT we are connecting coupling capacitor. Had we drawn that circuit standard op-amp, and then I have taught you how to even make it as a AC equivalent. All of you were present last time? Mostly all are on track, nobody is. Even if you are missing the lecture, you have to complete that at your home. So I guess that all of you have come prepared with the DC analysis and AC analysis, how to draw equivalent. So these two things will be of great help for us. So let us solve one problem. Now all of you are on track. Whatever was covered in the last session, now what we are going to cover. So we will solve two problems today. So that, and that too will not solve problems from anywhere. We will take the problems from previous university question paper. We will solve those problems so that it will boost your confidence. So let us start with the first example. Is the recap clear to you, whatever we have got? First, again you tell me what all are the different biasing circuits. Fixed bias, self-bias, collector to gate bias. Which one is most widely used? Self-bias. But since my strategy is always from simple to complex, I will take one fixed bias amplifier circuit. Then I will show you the steps first, and what is the most expected question in exam as per your syllabus is common emitter configuration with self-bias RE analysis. If you will see the syllabus, it is clearly mentioned that numericals are expected on common emitter configuration with self-bias, with bypass capacitor and without bypass capacitor. So we will solve 4 to 5 examples in due course of time, and that will cover this chapter in the complete way. It will complete the chapter by all means. You can check the syllabus. We have covered all the things. We have seen DC load line, we have seen common emitter characteristics, right from this BJT construction, we have seen entire things. Now the only thing which is left is the most difficult out of this chapter is AC analysis of biasing circuit, that too common emitter configuration, that too self bias. But to move from simple to complex, we will take some simple example and then we will move to little complex problem. So let us take down first numerical. I expect all of you note it down step by step, and if you have any difficulty, you are feel free to ask me then and there only. There is no doubt that you should not keep any doubt once you solve this problem, because there will be just change in numbers, mostly the format of the questions will be same. So first problem we will take, which will be based on fixed bias. It is not like that they will ask only on this. They may ask fixed bias circuit analysis using RT model. Fixed bias circuit analysis using RT model. So what was the first step I have told you to find RE? Correct? For finding out RE, you have to use our DC analysis step. We will find out IE by using DC analysis. We will not consider AC input by that time. So first numerical example 1. All everything correct? Understood up till now? Yes. Had I connected the previous topics with the coming? Yes. So fixed bias circuit. Even they will give you some problem like this. Now all of you are familiar with the fixed bias circuit. So this was the fixed bias circuit, correct? If I want to make it as an amplifier, what I will have to do? Why this is introduced? See, it is not playing any major role, but still for AC amplification, it is always shown. What is this symbol? Sign wala AC signal ka symbol. So let us say that this is VS or VS. Let us say that this is VS. And V out. This is CO, generally referred as. This is what RC, correct? What is this resistor? Is called as in fixed bias circuit RB. This drop around you are knowing VBE. This BJT is having its own characteristic or the specification beta. Beta is given in the problem as 100. RC is given as 1K, RB is given as 150K, and what they have asked, find ZI, ZO, AV and AI. Can anybody tell me what is AV? AV is voltage gain, voltage amplification or voltage gain. AI is current gain. ZI is input impedance. Why I am using the term as impedance in this case? Because since this is AC analysis is having capacitor, so there will be some equivalent capacitance. Whenever capacitance or inductance comes, we refer the resistance as impedance because it varies on frequency. Fine? So ZI, ZO, this is a typical problem they will ask. VCC given is 15 volts. They will give some values. If by mistake, suppose they forget to mention some values, we have to assume certain values clearly mentioned. At times they may forget to give VCC. Don't assume it as 100 volt or something. 15, 20, 22 is standard practice that all BJT operates on. So is that clear to you? This is the problem given. And what they have asked, whether input and output is clear to you, they have given an amplifier circuit and they have asked you to find out the input impedance, output impedance, AV कितना है, AI कितना है, ये सब पूछा है. तो मैंने आपको whatever I have told you in the last lecture, I have asked you to find out first step or step 0 I said. Step 0 बताया था मैंने to find out RE, because everywhere when you will draw AC equivalent circuit you have to find out, you need to know RE, small RE. What is the forward dynamic current of emitter junction? I, that is forward bias diode. Correct? We have seen the step by step R parameter model. So now consider this portion only. VCC कितना दिया है? 50 volts. How much is RB given? 150K. This is given as 1K. VPE, this time there, this is university problem I have taken as it is. VPE they have specifically given. So do not take your own value, do not assume your own value, whatever they have given. If they are not given, standard practice is to assume 0.7. But if they have given specifically as 0.6, 0.3, based on make of the BJT, you have to assume that value. So they have given VPE as 0.6 volts. So how can I get RE? I need to find step 1, let us say, to find RE. To find RE, what I need to know, what I have said, RE is 26 millivolt upon IE. So I must know IE, emitter resistance. How will I know IE directly? I can find out IB by using which loop? I can either use this loop. This is the only loop where IB comes into picture, because this is IB. The base current which is flowing inside the base is called as base current. So this is the only loop. All of you agree? Yes. To find RE, find IE. Hence IB. KVL to loop 1. Say loop 1. Then this is the, as I have told you how to apply KVL, 15 volt, other side is negative, this is rising potential. So 15 volt minus IB into RB minus VBE is equal to 0. Now this is, so what will be IB? IB will go this side. So 15 minus VB is given as 0.6. 15 minus 0.6 is 14.4 divided by RB 150K. Can anybody tell me what is the answer? You practice operating your calculator in the class itself so that there won't be any problem at the end where you have to put kilo ohms. You can use engineering mode if you want, if you are comfortable. In your calculator there is an engineering mode, so you can use that. So just tell me this value. Sorry? 0.096, it must be milliamperes. 96 microamperes is what I am getting, because this is kilo and this is divided by 150. So kilo will go above as milli, but this ratio is 0.00 something. So if you convert it into micro, it will be 96 microamperes. Is it clear? Yes, sir. Now IE is equal to 1 plus beta times IB. So it is 101 times 96 microamperes. So it comes out to be 9.69 milliamperes. Is there any doubt? Now what must be the next step? RE, very correct. RE is equal to what? 26 millivolts divided by IE, that is 9.69 milliampere. Both are into milli, so they just divide these two figures. You will get some value. It will be around 2.68 ohm. Is there any can say step 2 you can say draw AC equivalent. What rule I have told you for drawing AC equivalent? The capacitor should be considered as short. So this is shorted, so there is no impact. Then what I have said for DC sources. DC sources you have to assume it as ground. That means this terminal, this wire I will take it and connect it to ground. So this terminal is here itself, but the other terminal will come down over here with respect to ground. So this will come over here with respect to ground. This you can say show it like this also, or you can say show it like this also. What is this value? RB. What is this? BS. Now let us assume that here we have to draw what? We have to draw RE model. Let us not draw it first. Let us try to draw both the sides of BJT amplifier by using AC analysis, and then what will come over here? If I take this wire over here, because this is on this side, collector is on this side, this terminal I am grounding, so this will come at the output side. What will be this? RC. Very good. RC. What will be this? V out. Very good. Now what is remaining inside the box? It can be seen as a two-port network, where port means what? Pair of terminals. So for C configuration, the typical circuit or the circuit which I have told you is the collector side can be seen as a constant current source with value beta IB, and this emitter to base junction can be seen as a forward diode which has internal resistance with the value that we have seen last time as beta RE. Okay? Is there any doubt? AC equivalent circuit. Take your own time to focus on whatever I have drawn. There should not be any doubt. If you have understood previous lectures, RE model, this we have found out RE, so that we can find out the overall analysis ZI, ZO, AB, AI. Is there any doubt up till now? Clear? Last bench. All of you are with me. I am going very step by step in a systematic way. If you follow these steps, no numerical will go wrong. Only care you have to take is practice on calculator wherever kilo ohms is there, wherever milliohms is there. That you have to be very particular. Without making any mistake, we will solve these problems. As our target is what? 75 plus, as I am telling you repeatedly. So you must solve, attempt numericals wherever possible. Do not depend only on theory. Always solve the numericals, which will increase your score. And the third step, AC equivalent draw from here. Step 3. What is step 3? Find parameters. Ask. Here, before that, let us mark our standard practice. As a standard practice, we will mark, since this arrow is shown like this. This is IC. This is IB. suppose if I apply some input source over here, whatever resistance seen by these terminals is called as ZO. So let us find out Zi. In order to find out Zi, we have got two permutations. One is impedance seen at, this is what? BJT terminals. This is at BJT. What will be Zi? Can anybody tell me? Zi at the BJT level. Resistance seen by this. Here it is open. So only resistance is what? Zi is equal to beta times Re. That is 100 times Re. How much we have found out Re? Can anybody tell me? 2.68 ohms. So how much it comes out to be? Zi comes out to be 268 ohms. Is there any doubt in Zi at the level of BJT? Zi, the resistance offered at the BJT terminal. Correct? What will be the resistance seen at this terminal? Can anybody tell me? Enough inputs are given. Zi dash. Let us say that Zi dash. How much is the resistance seen in these terminals? RB parallel beta Re. Why? Because they are parallel resistors. Both the nodes are at same potential. So these two resistors are in parallel. All of you agree? So Zi dash will be a what? Beta Re parallel with RB. I have told you how to find out the equivalent of parallel resistors. What is the equivalent of parallel resistors? R1 R2 upon R1 plus R2. That derivation also we have seen. How the parallel resistance are to be calculated during foundation course. So I hope that you are familiar with Ohm's law, parallel combination, voltage divider rule, current divider rule. Now all of you are familiar. So please tell me this value, anybody? Beta Re we have found out 268. RB we have, RB is directly given 150K. Anyone? How much? 267 point. Very good. Ohms. I will tell you some cross checks wherever I feel I convey it to you. Parallel combination of two resistors is always less than the least value of the resistors. Now what is the least value of the resistors? 268 ohms is there and the other one was 150K. So the equivalent will always be less.
So 96.19.
What? Zi dash? Never it will come like this because it will be lesser than 268 ohms. And that too it will be less by, because current always takes the least resistance path. So least resistance path, that means that whatever is the equivalent, it must be less than that of the least value. ये बहुत ही important tip है आपको, so that you can cross check your answers. Always 267 आया क्या? अरे आप वो किलो कंसीडर नहीं, 150 क्या रहेगा? 150K है वो, 150,000 है वो, please. That's why I am telling you that repeatedly calculators you must read. Now all of you got mistake. You learn from your own mistakes. So 267.52 ohms. Zi dash. Is there any doubt up till now? So immediately if these values are correct, here it is correct. Out of 12 marks, you will directly keep it in mind that 6 to 7 marks you will allocate up to this. Because you have done your DC point, Q point, and then draw DC analysis. So the next step is 2.0. 2.0, the resistance or impedance offered at the output resistance. So what will be the ZO over here? Here it is as good as open. So only resistance which is there is RC. So ZO is equal to RC because at the BJT level the output impedance of this is very high. Okay. So this is having infinite resistance, so only resistance is RC. So ZO equal to RC, RC is 1K. So here again he will give 1 or 2 marks. Now to find AV. What is AV? Voltage gain will be what? V out upon V in or Vs, whatever nomenclature you use, it hardly matters. Let us say Vs. V out upon Vs. Correct? Is there any doubt? What is voltage gain? Output voltage upon input voltage. As simple as that. How to get this output voltage? As I have said, this is an open loop. So whatever is the drop across this resistor, what is the drop across this resistor? Since we are assuming the direction of current like this, so it must be minus IC into RC. The drop across collector current resistance is V out. This drop is V out, but as on the day one we have assumed the directions of current like this, input side, output side both are coming this like this. So this is minus ICRC. V out is minus ICRC. What about VS? What about VS? It is not fixed. You can relate it, the drop across this, because drop across this and drop across this is same. So it is IB is going to this, IB into beta times RE. But beta IB is what? IC. Beta times IB is what? IC. So minus IC into RC divided by IC into RE. What will get cancelled? IC will get cancelled. The ratio comes out to be minus RC is 1K divided by RE. Small RE we have found out 268. Correct? 2.68 ohms. Tell me what is this ratio? Tell me. 373.13. Very good. 373.13 with minus sign. What does this minus sign indicate? You know, it indicates that suppose input is applied like this, output will be 373.13 times more, but with so this is voltage gain. Voltage gain समझा आप लोगों को? Suppose if I apply some more value, if I apply 1 volt peak to peak, will it go to 373 volt peak to peak? Just question I want to ask. Will it go up to 373 volts? Why? It will restrict up to 15 volts because that is the highest value. Power supply उसके पास है ही नहीं उतना, तो how will it give? Faithful amplification है ना, तो आपको इनपुट ऐसा देना है कि it will not go into saturation. Otherwise, there won't be faithful amplification. So AV is clear to you, and the last step is to find out IS, AI, to find AI, current gain. Can anybody tell me what is the current gain? AI is equal to IC upon IS. Output का current divided by input का current. Okay, output current by input current. We cannot directly find this ratio, but what we can do is we can find the ratio between this and this, and multiply this and this. So I will show you over here. This can be derived as IC upon IB into IB upon IS, because IB gets cancelled, so it is same IC upon IS only. But we know this IC upon IB is what? Beta of a resistor. So this is beta into IB upon IS. How will I get to find IB upon IS? How will I get IB? This is IB, this is IS. Do you know the relation between two currents in parallel branch, current division rule? IB upon IS. What is the relation? The current through this R is this resistor, opposite wala this resistor, divided by sum of these two into the current supplied. So if I take IS on this side, I will get RB upon RB plus beta I. Correct? Current division rule. If you have that time I have explained to you how to get voltage division rule by simple KVL or by simple Ohm's law. The current division rule. Here you can write down. अगर आपको during PL there is some doubt, so this is the reference, current division rule. So this is because of current division rule. So please tell me this value. RB you are knowing. RB you are knowing. RB is given 150K divided by 150K plus beta R. Beta R we have found out somewhere. Beta R is 268 ohm. Please tell me this ratio. Tell me this ratio RB upon RB plus beta RE, that is 150K divided by 150K plus 268. It comes out as 0.99. Correct. But is this the AI? It is not AI. AI is beta times this ratio. Na? So AI is equal to 100 times 0.99. So 99.82. Here if you go up to this, 99.82. Will there be any unit? Because it is the current gain, output current upon input current. So it is the ratio. Whenever there is a ratio, there won't be any unit attached to it. But for Zeta and Z1, do not forget to write ohms, kiloohms. Okay? So this is the ratio. So this has completed your numerical of 12 marks, 12 to 15 marks. See, you will get option. You will get option. As per the question paper pattern discussed, you will get option. Either you can attempt the theory questions which I have circulated to you. Why the base is lightly doped and this. That type of question will be there. Or the second question will be there. There will be two numericals. So if those who will attempt the numericals and solve it correctly and systematically, they will score more. Keep this much in mind. And our target is not just to clear the subject or get 35-30 marks. We have to get 75 plus. I am repeating this, whatever I say, it becomes clear. So that is why I am telling, I have taken this problem so in a step-by-step way. You have a look over it for 2 minutes. I don't mind spending 2 minutes, but with a conscious thought process, see what we have done. Just see, and if there is any difficulty, मतलब आपको समझा ही नहीं ऐसा कुछ है, तो प्लीज बताइए मुझे. If you follow these steps systematically, your answer will never be wrong. I can challenge that your answer will never be wrong. problems are expected as per your syllabus, that I will draw it over here now. Earlier problem, step by step. First what you will find out? RE. For finding out RE, what you will find out? You will try to find out IV. IV से आपको मिलेगा RE. 26 millivolt divided by RE, you will get RE. So then you will draw the AC equivalent circuit. Beta RE on the, because since it is the forward bias junction diode, so beta RE. On the output side it is current source, constant current source. Okay, so that model you will keep it in between. You will replace BJT by that RE model, and you will take DC to short to ground, capacitor shorted, and then you will find out the parameters. ZI resistance seen through the input terminal, ZO resistance seen through the output terminal, AV output voltage divided by input voltage, AI output current divided by input current. So if you follow these steps, you will never be wrong. So the next problem, as per your syllabus, you will see clearly syllabus, it is CE amplifier analysis using RE model. Earlier one was also CE amplifier, but with which type of biasing? It was with the fixed biasing. But the most preferred combination is self-bias along with common emitter RE model. So this will be the most important problem. There are two variants in this. One is with bypass capacitor, the other one is without bypass capacitor. So whenever there is a capacitor involved in AC analysis, that capacitor needs to be shorted. Okay, so try to solve this problem plus VCC. Again, this is university unsolved example of previous year. It is 22 volts given, RC is given as 6.8 K. The value they will never give. Don't get confused. Value here. This coupling capacitor, standard capacitors they use. R1 is given as 56K, 8.2K, 1.5K. Beta is given as 90. Whatever value they give you, BT is given as 0.7. Now I have introduced you the topic. You people are matured enough. Now you only tell me where there will be a difference than previous problem. Earlier it was simple circuit. There was only one base resistor RC. अभी क्या करना पड़ेगा हम लोगों को? पहले तो क्या फाइंड करना है? IE. That too it will be based on the Q point. So for Q point, which technique we have used? We have used Thevenin's theorem. तो चार रेजिस्टर है, ठीक है? So RTH you find out as R1 parallel with R2. VTH you find out as potential across the lower resistance. How do you find it out? R2 upon R1 plus R2 into VCC. So you got VTH, RTH. So you will draw Thevenin's equivalent circuit. Just draw up to now, up to this point. Just find out VTH and RTH values and tell you. Then some of the steps I will skip and try to get the answers from you so that you will also feel confident. We have solved similar 3 problems, but only thing is that there was no input voltage applied. Input voltage is Vin, not VCC. VCC is the biasing. Somebody should take me the value of BTA. Let us see who does it first. Yes, BTH. Which one? R2 is 8.2K. Fast, because it will take less time to solve. With the pool net you have to solve. Anybody will BTH, anyone. 2 point. आपने क्या किया 8.2K divided by 8.2K plus 56K into 22 किया क्या आपने into 22 ही करोगे तो कैसा है 2.81 आया है 2.81 so VTH or for simplicity, since this is connected to base, I will say VB equal to 8.2 divided by 8.2 plus 56. I will not add K because what both are K, kilo. So it means 2.81 volts. VB आ गया. No need to apply KVL. You can use simple tricks also. If I got VB, I can find out VE. How I can find out VE? VE is equal to VB minus VBE. 2.81 minus 0.7. 2.11 volts. Can I find out IE? How can I find out IE? VE upon RE. That is 2.11 divided by RE 1.5K. And once I get IE, I can find out RE. 26 millivolt. Take your, I am giving you 2 to 3 minutes to digest what I have written it on the board. There are different ways to get IE. To get IE, you can go with different ways. You may say that, sir, earlier though we used to apply loop KVL to the loop side and then we used to find that way also you can do. But the simple thing is there, I am going VB, I am going VBE. I can find out the drop across resistor RE. So VE I have to find it out. Once I know VE, DC current will not pass through this capacitor, so it will pass through only this. For DC it acts as the open circuit. So the current going through, you can find out by VE upon RE. RE is given as 1.5K, you will get 1.41 milliamperes. And then RE is equal to 86 millivolts upon 1.41 there any doubt? RE का समझ में आया? Now AC Why I have shorted this? Why I have bypassed RE? Because when AC is applied, capacitor acts as a short circuit. So for AC, now here there is a short circuit, and here there is resistor. Which path current will flow with less resistor? This is short. So equivalent to this becomes short. So this is RB. This is VTH. RC, this is what we have drawn. Now, AC equivalent circuit can be drawn by this. So this RC will come to this side, RB will on this side, and the AC sources we are keeping it to ground. Here, in the AC analysis, this is V in. So here it is V in. Sorry, here we have forgot to draw. This is the AC equivalent. See, with this, I have kept RB as it is on this side. In case of AC analysis, DC sources should be treated as ground, so that terminal RB followed by VTH that RB will directly go to ground. This box is nothing but the RE model. RE model can be replaced as beta RE at the input side, and at the output side it is constant current source with the value beta IB. RC, that resistor, I will take it to ground, so that will go to the output side. So this is RC. Is there any doubt in AC equivalent? VTH, see, instead of giving name as VTH, I have given it as VT, just name. Thevenin's voltage only we have found out, but that is applied at the base. So there should not be any confusion like why VTH, what is VTH? So it is nothing but base voltage. That's why VT. VTH equals VT. And these steps we have followed. Then AC equivalent, DC equivalent, ये draw किया आपने. Can you solve AB, AI, ZI, ZO? Same. Once you have got this circuit, here it is same as that of the old circuit, previous one. Same things you have to follow and give me the answer. That will be checked in the form of tutorial. So is that clear? So I request you to please take the attendance.